Okay, Algebra 2 skills number 27, vertical asymptotes. So what is an asymptote exactly? An asymptote is a line that a graph approaches more and more closely. Sometimes the graph crosses it, sometimes it does not. So we're going to look specifically at a vertical asymptote. So how to find one? Vertical asymptote, you set an uncancelled denominator factor set equal to 0. We'll specify exactly what that means in a moment. But we also have a hole in the graph, which is very similar. That's when you set a cancelled denominator factor set equal to 0. So what's the difference between an uncancelled and a cancelled denominator factor? Let's take a look. So our first example, find the vertical asymptote. So notice this rational function y equals x minus 6 over x minus 4. Nothing will cancel here. This is an uncancelled denominator factor. So if we set that equal to 0, x minus 4 equals 0, then simply x equals 4 is what you would get if you added 4 to both sides. This is a vertical asymptote because this is an uncancelled factor. Okay, it didn't cancel anything. And we'll show you what a cancelled factor is in just a moment. But looking at the graph of that, here's x equals 4. X equals is a vertical line. And notice it's an asymptote because the graph, and the red here is the graph of the function x minus 6 over x minus 4. And you can see it approaches on both sides, that blue line, more and more closely. And it actually will never cross that if you were to extend that graph. A second example, it says here find the vertical asymptote and hole in the graph. So we're going to have both an uncancelled factor and a cancelled factor on the denominator here. Let's check it out. So y equals x plus 2 over x squared minus 9x minus 22. If we factored the denominator, you can get x minus 11x plus 2. And notice the red here shows that x plus 2 can be cancelled. So the vertical asymptote would be setting the uncancelled. That's not going to cancel. So if we set that equal to 0, we get x equals 11. That's your vertical asymptote. But if we were to cancel that, which I won't actually cancel it here, this x plus 2, but if we were to cross that off, it would become 1 over x minus 11. But I'll leave it in red here for you to see that the hole in the graph would be this cancelled x plus 2 set equal to 0. If you were to set that equal to 0, you get x equals negative 2. But it's a little tricky here because a hole in the graph is an actual coordinate, not a line. So you don't just say x equals. You have to take negative 2 and plug it back into the original equation. And if you were to do that, you would get negative 1 over 13. If you were to put negative 2 into the bottom here, it would make negative 13. And remember, there'd be a 1 on top there. So negative 2, negative 113 is a hole in the graph. So x equals 11, and then negative 2, negative 113. If you were to look at the graph here, here's x equals 11, okay? And then negative 2, negative 113 would be right there. It doesn't actually show up on this Desmos graph, but it would be right in that area is where there's actually a small hole in the graph.